Hey everyone, hope you guys are having a fantastic day. So, yesterday, gave you guys a little challenge, right? It was pretty difficult, not gonna lie. Uh, and I've been pondering it, so I'm gonna go over how to do it real quick. Uh, and I told the people who were on the Google Meet at the end of class the right equation, but I told them the wrong explanation. Okay, and that was my bad. And I'm going to try to clarify that a little bit in today's video. And then I'm going to introduce another assignment. So what I'm going to do is I'm going to present my screen so you guys can see what I'm showing you. All right, so hopefully on this investigation, what you guys, is the problem said you must find the final momentum of the minivan first. Okay, so in our scenario, okay, there was a car traveling certain speed. There was a minivan stopped, right? The minivan was stopped. However, after they collided, the minivan started moving until it eventually stopped again. Right? It skidded to a stop, which we know is 22 meters, right? I told you guys that factor. Okay? So that's information we kind of know. Now, I'm trying to find a pen I can write with. This will work. Okay. So we know we have to solve based just on the minivan itself, okay? So the minivan itself traveled 22 meters and eventually came to a stop. Okay, well, there's one force acting on it, and that force is friction. Okay, so we know that we have to solve for the force of friction. Okay, can't see that. There we go. We know we have to solve for the force of friction. We know that the force of friction is equal to mu times the normal force. Okay, where mu was given in the problem 0.850, and the normal force is just the mass. So the entire mass of the minivan, I got to be 1,895.2 times gravity. Okay. So here I got the force of friction to be equal to negative 115,787 newtons. Okay, so that's the force of friction. Now, from there, our goal is to solve for the acceleration, okay, so that we can solve for the initial velocity. So from there, hopefully you thought of Newton's second law, where we can plug in the force, and we know the mass. The mass of the minivan, once again, was 1,895.2. And you can solve for A. Okay? Where A is equal to negative 8.33 meters per second squared. Okay? Let me zoom out just to show you where we're at. Okay? From there, okay, hopefully you guys knew that skid mark was 22 meters and you realized velocity final squared equals velocity initial squared plus 2ax. Okay, well, velocity final squared is just 0 because based on the minivan, this is after the collision. Oh, you can't see. After the collision, this is what we're focused on. How fast did it initially move after the collision? Right? So how fast was it going? Right? And after the collision, it eventually came to a stop, right? So our initial is going to be moving, eventually came to a stop. So velocity final is 0. Velocity initial is what we're solving for, plus 2. A was negative 8.33. X is 22. Oh, okay. So when you solve for the velocity initial, you should get a number around 19.1 meters per second. Now, this is the tricky part. I'm going to zoom out. So my initial velocity, so I'm going to draw my cars once again. This car hits this car, and that car skids 22 meters to a stop. Okay. So that was focused on this van, right? Only the van. That's all I was worried about. The initial velocity eventually came to a stop 22 meters later. Now, when looking at the collision, I'm not worried about all this now. When only analyzing that fact right there, okay, we have to consider all our numbers, okay? So change in momentum initial momentum is equal to initial momentum final. So mass of the minivan, initial velocity. I'll do the Mustang actually. We'll make plus mass of the van, initial velocity of the van. Mustang, final velocity of the Mustang, plus mass of the van, final velocity of the van. Okay. So when we're looking only at this collision now, we're not worried about anything else. We are only focused on the moment of impact. So right there, the initial velocity of the van's not moving. So right there, the van's not moving. So our initial velocity is 0. Right? Right when that hits, our initial velocity is 0. So we can get rid of that. Now, what's going to happen is right on that collision, all the momentum is going to be transferred. When that hits, all the momentum is going to be transferred to this car, the van. All of it's going to be transferred to the van. So this car is going to come to a stop. So after the collision, this car stops, which means we can get rid of that. Whereas the van will get that momentum. So the final, after the collision, after that collides, the final momentum is actually all transferred to the van, and that's where we're going to get that number. Where we already calculated that, right? Because we know that after the collision, we calculated that velocity. We already know that. My velocity is 19.1. So that's what you plug in there. So it is interesting because when we're only focusing on the van, that was initial velocity, right? That was the initial velocity that brought us to a stop. However, when we're looking at the collision part of it, that's the final. That's how much momentum the car finalized into the van. Okay? So the mass of the van, once again, was 18.95.2. Oh, 1895.2. Okay, so you're going to multiply those two numbers. You know the mass of the Mustang.
Mrs. McReynolds, please see Mrs. Patterson in the comments.
It's 12.6. And then you're going to multiply that by the initial velocity of the car. So, all in all, the initial velocity of the Mustang, the final answer, if you guys got that far, was 29.4 meters per second. So, the car actually was going around 60 miles per hour, probably. It's pretty quick. Okay, so anyway, I wanted to start off by explaining that in a little more detail, okay, of how to solve that. So today, well, actually, I can introduce today's activity. So today, what we're actually going to do is we're going to do a little collision virtual lab. Okay. Now, collision, it's basically the same equation, right? Or explosion. We're doing explosions. I'm sorry. Momentum initial, momentum final, right? Where my momentum initial is mass of object 1, mass of object 2, times the initial velocity. Where when something explodes, well, it separates into different pieces, right? Separates into different pieces. Okay. And if you think about it, before an explosion, most cases, its velocity is always going to be 0, which makes our problem so awesomely easy. Okay? In most cases, our initial velocity is 0. So our initial momentum is 0, which means our momentum final also has to be zeros. Okay? Because because sometimes what happens is this moves to the left and that moves to the right. Okay? And that's what our virtual lab is going to do today. Okay? What you guys are going to do is what I posted in classwork is explosion homework. Okay? So if you view the assignment and the PDF, I would recommend using Cami to edit this. You're going to get different masses of blue and red cards. Okay? So let me open this link. Okay? And you can click, make it larger. So begin. Okay? Now you can adjust the mass of all this. You can go up to 2. You can go down to 0.5. Just vary it. Okay? And click explode. It gives you the speed, okay, in centimeters per second. So what I want you to do is go back to this assignment and put in the mass of the red, mass of the blue. What was the speed in meters per second? Okay, convert that to meters per second. Should be all right. And that's of the red car and the blue car. Okay, and then answer some questions. What was the individual momentum of the red cart before the explosion? It's not moving, it's 0. What's the momentum of the blue car? Not moving, it's 0. What's the combined momentum? It's not moving, it's 0. Okay. And then calculate, let's see, trial post-explosion momentum. You're going to calculate momentum. So what is the mass of the cart times the speed? You're going to need the mass times the speed. Okay. And analyze some of these questions, okay? So try your best, okay? Try your best on this. If you guys have questions, I'll be close to my computer most of the day today. So just let me know, shoot me an email. If not, I hope you guys have a fantastic weekend. We'll continue with explosions on Monday, okay? We will see you guys later.